Here we have another inequality to solve. This time it's a rational inequality. So we have x minus 5 over x squared minus 9 less than or equal to 0. So we're going to do a plus minus analysis on this expression on the left hand side. And on the number line we'll put the zeros of the numerator and the denominator. Well, x squared minus 9 factors, that's x minus 3, x plus 3. So on the number line we're going to put 5 for the 0 from the numerator and 3 and minus 3. Those are the zeros from the denominator. So let's do that. Let's do our plus minus analysis right here. Okay, so I'll copy over our expression that we're analyzing. Because a plus-minus analysis shows us where this expression is positive and negative. And here we want to know when it's less than or equal to 0, where it's negative. So that'll give us the information that we're looking for. Okay, so on the number line, remember we put in order, we put the zeros of numerator and denominator in order. So we'll start with minus 3. Open circle for minus 3 because 3 is not in the domain, or 3 makes the denominator 0. All right, and then comes 3, also open circle. And then comes 5, okay, closed circle for 5. And now substitute in values. We substitute in 6, 6 minus 5, 6 minus 3, 6 plus 3. Those are all positive, so we get something, a positive value. So everything's positive. This expression is positive to the right of 5. Again, we only had to substitute in one value, so we did 6, which is to the right of 5. Here, in between 3 and 5, we can substitute in 4, for example, and we'll get negative here, positive, positive. So the whole expression will be negative. Here, between minus 3 and 3, we have 0, so let's substitute in 0. We have negative, negative, positive, 2 negatives, so that's positive. And to the left of minus 3, we'll use minus 4. Here we have a negative, and then negative 3 negatives. That makes the expression negative. All right, now we want to see where is this less than or equal to 0. So shade in less than or equal to 0. That's negative or 0. So let's shade in the negative parts of the interval. All right, now we are including 0. All right, so let's list the intervals that for which x makes this expression less than or equal to 0. So to the left of minus 3, that would be from minus infinity to minus 3. Do not include the minus 3 because of the open circle. Okay, our expression is not 0 there. There's a vertical asymptote there. All right, and then we have the other part of the interval here. And we're going to not include 3 because that's where we have a vertical asymptote. But 5 is a 0 of the expression, so put a square bracket next to 5. We are including 5. Here's another rational inequality. And to start with, we need 0 on the right-hand side. So we're going to subtract 1 from both sides. So we need 0 on right-hand side. So to start with, subtract 1. And now we want to write this as a single fraction. So we'll get a common denominator and subtract. So we're going to subtract 1 is x minus 5 over x minus 5. Okay, let's subtract. So we have 3x plus 1. Be careful to distribute that minus. So we have a minus x. And here we have minus 5. Minus 5, so plus 5 over here. Okay, let's write this a little simpler, in a little simpler form. We have 3x here. 3x minus x, that's 2x in the numerator. And then 5 plus 1 is 6. All right, we want to put the zeros of the numerator and denominator on the number line and do a plus-minus analysis. So now that we have 0 on the right-hand side, we're ready for that. But let's just factor out the 2 from the numerator here. So after we do that, we see the 0 of the numerator is x equal minus 3, and the 0 of the denominator is x equal 5. So we'll put those, we'll do our plus-minus analysis. All right, so I'm going to write the expression next to the number line. That's what we're analyzing. And we're putting a minus 3 closed dot, because that's from the numerator. And 5 gets an open dot, because that's a 0 of the denominator. Then when we do the plus-minus analysis, substitute in 6, for example, and we have positive over positive. Substitute in 0, which is between minus 3 and 5, and we have positive over negative, so that would be negative. And substitute in, let's say, minus 2 here. That would be negative, negative. 2 negatives is a positive. All right, now, so here's a plus-minus analysis. Now, what are we looking for? We want to know, when is this greater than 0? Greater than 0, so that would be here and here. And we're not including the zeros, so that we won't include this 0 here. So that's from minus infinity to minus 3. And open bracket here, a round bracket, don't include the minus 3. And then open bracket around 5, or open parentheses around 5, to infinity. Okay, and now on to our first graph. All right, this is the polynomial that we want to graph. Let's first notice that we could pull out a 3 from this first set of parentheses. So we have 3 times x minus 3, and then x minus 5 squared. All right, let's get our basic information. X-intercepts, starting with x-intercepts. Since this is factored, we can just read them off. That'll be x equal 3 and x equal 5. All right, let's do y-intercept. Substitute in x equals 0, and we have 3 times minus 3 times minus 5 squared. That's equal to minus 9 times 25. So that's minus 225. And now let's do the end behavior. Well, our function has the following first term. We have 3 times x, and we get an x squared from here. So that's 3x times x squared, that's 3x cubed, plus other terms. So as x goes to infinity, 3x cubed goes to infinity as well, so we'll write y goes to infinity. And as x goes to minus infinity, 3x cubed also goes to minus infinity, so we'll write y goes to minus infinity. So in other words, that means up on right, and then we have down on left. Okay, now we're ready for our plus-minus analysis. And maybe we'll do, all right, here we'll do the plus-minus analysis, and then we'll do the graph. All right, so here, let's write our function next to our number line. Okay, here's the number line. So on the number line, we're just putting 3 and 5. Both closed dots. There's no denominator here. All right, if we substitute in something bigger than 5, like a 6, for example. So here we have something positive, something positive. Notice this is squared, so whatever we substitute in here will be positive. All right, let's say we substitute in 4, something between 3 and 5 or 4. So this is positive, and this, because it's squared, is still positive. And let's say we substitute in a 2 to the left of 3, and this is negative, and this is still positive. Okay. So notice we don't have the alternating pattern here. We have two positives in a row. And how did that happen? Well, that happened because of the x minus 5 squared. Notice it happened at 5. Okay, and 5 is on the number line because of the x minus 5 squared. So this exponent, this even exponent over here, caused the alternating pattern to be interrupted. All right, so here we go from, the graph is negative below and it goes to positive above, so I'll put a crossing point here. And here it stays positive, but it's going to come down to 0 because 5 is a 0 of our function, and then it stays positive, so it just touches at 5. Okay, it goes up on the right, down on the left, so we have it going up here and down here. So from the plus-minus analysis, we can see more or less, what the graph is going to look like once we connect everything. All right, let's go and draw a little bit more accurate graph, but not much more accurate, just a little bit. Let's draw, let's plot our function now. So first I'll put in the x-intercepts. That's 1, 2, 3. There's 1. 4, 5. There's the other one. Let's put in the y-intercept. Well, that's all the way down here. Let's say, let me put it over here at minus 225. All right, and this is our crossing point, and this is a touching point. And the graph goes up on the right, and it's going down on the left. So if we just connect the points, it looks like we'll have something like this. Now, it's not necessary to include more points, but if you want, you could substitute in 4, for example, just to see the value of some point in between 3 and 5. So if we do that, if we substitute in 4, we have f of 4 is equal to 3. 4 minus 3 is 1. 4 minus 5 is minus 1. Squared is 1. So we get 3. So this point over here is 4, 3. Okay, so that's our rough graph.